Assalamualaikum. We will be presenting about Candida Auris. This is my group members, which is Nisrin Hayati binti Mayudin, and that's me, Nur Ila Istihab binti Muhammad Asrin, and that's Nur Atira Sofia binti Abdurrahim. Candida auris, a relatively newly identified fungal pathogen, has emerged as a significant global health concern due to its multi-drug resistant nature and propensity to cause severe infections, particularly in healthcare settings. This introduction will provide an overview of Candida auris, its classification within the framework of the Five Kingdom classification, and its scientific identificator through binomial nomenclature. According to the Five Kingdom classification system, organisms are categorized into 5 major groups based on their characteristics. The first one is kingdom, which is fungi, and then phylum, Ascomycota or sect fungi, and then class, Saccharomycetes, and for others is Saccharomycetes, and for family is Saccharomycetaceae, and then genus is Candida, and lastly species is Auris. For the morphology of Candida auris is oval-shaped yeast cells measuring 2 to 5 micrometers in diameter. It has a smooth and uniform cell wall that facilitating adherence to surfaces, means that structure and composition of the cell's wall support its ability to attach firmly to various surfaces, which is essential for its persistence and pathogenicity in clinical settings. Under certain conditions, Candida auris can develop pseudohyphae, enhancing its ability to invade tissues and form complex biofilms. Production of a polysaccharide capsule around the cell wall may contribute to virulence and immune invasion. For nutrition, it is heterotrophic because it relies on external sources of organic carbon and other nutrients for growth and energy production. It does not have the ability to perform photosynthesis or chemosynthesis. The fungus metabolizes various carbon sources such as glucose, mannitol, and glycerol. This metabolic versatility allows Candida auris to adapt and thrive in diverse clinical environments, including those with fluctuating nutrient availability. For nutrition requirements, besides carbon sources, Candida auris requires nitrogen, phosphorus, vitamins, and trace minerals for various metabolic processes that play a role for growth and reproduction. And next is habitat, which Candida auris is primarily found in healthcare settings, including hospitals, nursing homes, and intensive care units. It connects skin mucosal surfaces and medical equipment, forming biofilms that enhance its persistence and resistance to disinfection. The ability of Candida auris to survive on surfaces and medical devices contribute to its role as a challenging nosocomial pathogen. For reproduction, Candida auris undergoes asexual reproduction, where it produces asexually through budding, where daughter cells emerge from the parent yeast cell. This efficient reproductive strategy allows rapid population growth, facilitating outbreaks in healthcare settings. It also contributes to genetic diversity among Candida auris strains, influencing their virulence and resistance profiles. For the significance of Candida auris, it can cause severe infections, including bloodstream infections, wound infections, and otitis. These infections are associated with high morbidity and mortality rates, particularly in immunocompromised individuals and patients in intensive care units, highlighting the pathogen's virulence and severe consequences of infection. And for multi-drug resistance, a defining characteristic of Candida auris is its resistance to multiple classes of antifungal agents, including azoles, echinocandins, and polyenes. This resistance complicates treatment, often necessitating the use of less common and more expensive antifungal drugs. The economic burden of Candida auris is substantial, involving costs associated with prolonged hospital stays, enhanced infection control measures, and expensive antifungal treatments. And for multi-drug resistance, a defining characteristic of Candida auris is its resistance to multiple classes of antifungal agents, including azoles, echinocandins, and polyenes. This resistance complicates treatment, often necessitating the use of less common and more expensive antifungal drugs. The economic burden of Candida auris is substantial, involving costs associated with prolonged hospital stays, enhanced infection control measures, and expensive antifungal treatments. Despite its notoriety as a pathogen, Candida auris has not been a subject of commercialization in terms of products or processes due to its high virulence and drug-resistant natures. However, it has spurred a significant advancement in diagnostic technology as antifungal research, indirectly contributing to commercial and scientific development. The rise of Candida auris has led to the development of commercialization of advanced diagnostic tools, which is PCR-based assays, or real-time polymerase chain reaction (PCR), have been developed to detect Candida auris with high sensitivity and specificity. The challenge of treating Candida auris infection has driven significant investment in antifungal research and development. The urgent need to effective treatment against multi-drug-resistant Candida auris has prompted the exploration of novel antifungal compounds. However, they manage to enhance disinfectants where manufacturers like Clorox and Diresay have introduced disinfectants with proven efficiency against Candida auris. These products are part of broader infection control strategies implemented in hospitals to prevent the spread of this resilient pathogen. In conclusion, Candida auris, a multi-drug-resistant fungal pathogen, is a serious threat in healthcare settings. It forms persistent biofilms and reproduces quickly through body. This pathogen causes severe infection, especially in immunocompromised patients, and resists multiple antifungal drugs, complicating treatment and raising healthcare costs. Its emergence has driven advancement in diagnostic tools and antifungal research.